Good evening everyone. So this is D.R.G.D.VIGNESH, Assistant Professor, Department of ECE. So today I am going to discuss about the basics of signals as well as transforms. So what do you mean by a signal? So a signal is nothing but a quantity, a physical quantity which keeps on changing with respect to certain parameters. For example, if I take a signal x of t. So this x of t is a signal which is going to vary with respect to time t. So it is varying. So this parameter is a function of the time t. So this is called as 1D, one dimensional or single dimensional signal. So normally signals are said to be of 1D type only. So based on this, there are different types of signals available. So first one is analog signal. Second, discrete signal. And third one, digital signal. So analog signal, discrete signal and digital signal. So first I am going to see what is analog signal. So analog signal is nothing but it is going to vary continuously with respect to time. So all real-time signals which are available in the environment or in the nature are said to be of pure analog signal. So they are also called as continuous time signal, continuous time or CT signal. So since they are going to vary with respect to time, they are called as continuous time signal. So here if you see the signal which I have drawn here, x of t. So it is an analog signal. So at each instant of time, it has got a value. It gives a value. So the number of values are going to be infinite number of values. So if we take the time interval from t1 to t2, I can say that between t1 and t2 time interval, I can give what? The signal x of t can take infinite number of values. So that is why, so it can take infinite number of values. Infinite number of values. So that is why it is called as continuous time signal. So one of the major drawback of continuous time signal is that they are difficult to process and also difficult to store in a particular memory since they are going to continuously vary with respect to time. So to overcome this drawback only, we are going to convert this analog signal, analog or continuous time signal into another signal called as discrete time signal. So they are also called as DT signals. So it is a derivative from, it is derived from continuous time signal by a process called as sampling. So I can write here CT. So it is nothing but x of t. It is an analog signal is converted into a discrete time signal or DT signal by a process called as sampling. So sampling converts my continuous time signal to a intermediate form which is called as discrete time signal or DT signal. So when I am going to discuss about DT signal, here in continuous time signal, both my amplitude and time are continuous in nature. So that is why it is called as analog signal. So when it comes to DT signal, x of t becomes x of n into ts. So By performing this sampling operation, I am able to convert this continuous time into discrete time samples. So if I draw the samples for DT signal here, so if it is taken as x of t, here x of nts, so it is nothing but a discrete time signal. So it is obtained by sampling the time interval at discrete instance of time. So this is 0, 1, 2. So at t equal to 0, it has got one amplitude. Here at t equal to 1, it has got another amplitude. So the time is discrete, whereas my amplitude is at v1. So if we join all these things, I can say that the amplitude is almost continuous and it is getting the envelope of my analog signal. So if you take here, so here what it is, amplitude is continuous and time is discrete. So amplitude is continuous and time is discrete. So this is about DT signal or discrete time signal. So it is obtained by a process called as sampling. So sampling is nothing but taking one or two time instance samples at one or two time instance and having the values. So this is called as sampling. So sampling indicates that I need to ensure that the sampling frequency Fs, or the number of samples I am going to take at a particular time instant, that should be equal to, greater than or equal to 2 times the maximum frequency of my input signal or input analog signal. So this condition has to be satisfied. So this is called as the sampling condition. Fs should be greater than or equal to 2 times the maximum frequency of operation, that is nothing but Fm. Next, the third type of signal we are going to use digital signal. So here digital signal is obtained from what? Discrete time signal or DT signal. So if I say x of nts has now become xn. So you can take 2 power n values. Xn can take finite number of values. So here what is the change that has occurred? Both amplitude and time are discrete. So we can take how many number of values? 2 power n values. So I am having fixed number of values in both amplitude as well as in time. So this is the clear differentiation between these three types of signals. So in continuous time signals or analog signals, both the amplitude and time are continuous. Next, in discrete time signal or DT signal, the amplitude is continuous but time is discrete. Whereas in the last case, that is my digital signal, both the amplitude and time are discrete in nature and they can take finite number of values of 2 power n. So where n can be 0, 1, 2, 3 and so on. So if we take, suppose, so xn is nothing but a digital signal which can take how many values? 2 power n values. So if I take n equal to 1, if I take n equal to 1, what will be the values of xn? 2 power 1, which is equal to 2. So xn can take two values, so it can be either 0 or 1. It can be either 0 or 1. So that is why we call it as, this is called as binary digital. Binary digital. Next, the next case I am increasing the value of n equal to 2. So here what will happen? It's becoming 2 square, which is nothing but 4. So n can take 2 bits at a time. So it can be the possible values of ranges are 0, 0, 0, 1, 1, 0, 1, 1. So there are 4 possible combinations. So this is called as quad or quadric digital signal. Similarly, if you take n equal to 3, so you get 2 power 3, which is equal to 8. So totally 8 possible combinations. So it will start from 0, 0, 0 up to 1, 1, 1. So they are called as what? Octal. And for n equal to 4, I can have 2 power 4, which is nothing but 16. So the possible ranges are 0, 0, 0, 0 to what? 1, 1, 1, 1. So they are called as hexadecimal. Like this, I can have different possible combinations for different possible values of n. So this is about digital signal. Now, I told that about the sampling theorem. So sampling theorem states that Fs should be greater than or equal to 2Fm. So again, I got 3 possible cases here. So sampling theorem, Fs should be greater than or equal to 2 times the maximum frequency or Fmax. So I got 3 possible cases. So first one, undersampling. Second, Nyquist rate or Nyquist sampling. And third one, oversampling. So undersampling means the sampling rate is going to be very, very small. So this condition is nothing but the sampling rate is less than 2Fm. Sampling rate is less than 2 times the maximum frequency. So when you have got this condition, the number of samples are going to pick is going to be very, very small to convert a digital signal. As a result, this will lead to a problem called as aliasing. So what will happen is that in the spectrum, the overlapping of signals will occur. So this is called as aliasing. The spectral components of the high frequencies will try to overlap with the low frequency components. So this process is called, this problem is called as aliasing problem, which should be eliminated. So to eliminate this aliasing problem, I need to ensure that undersampling is not preferred. So next is the Nyquist sampling rate. So this is nothing but the minimum sampling rate that should be satisfied to overcome this aliasing problem. So here Fs should be exactly equal to 2Fm. So this is the minimum sampling rate which is preferred to avoid this aliasing problem which is mentioned above. So here what will happen? There is no aliasing, so the spectrum will not overlap, just they do not overlap each other. So the aliasing problem is minimized or eliminated. Next, the third condition is nothing but oversampling. So the sampling rate is going to be very, very high. So what is going to happen? I got more number of samples. So Fs is greater than 2Fm. So what will happen in the spectrum is that the gap between the spectrum starts to increase. So there no longer the problem of aliasing is completely avoided by going for this oversampling approach. So this is the concept behind this sampling process. Now let us solve a problem. If the maximum frequency of the analog signal is taken as 4 kilohertz, then what will be the minimum sampling rate? Then what will be the minimum sampling rate they are asking. So this is a question which is given. So they are given Fm or Fmax. The maximum frequency of analog signal is taken as 4 kilohertz. They are asking what will be the minimum sampling rate. So this is very, very important. So minimum sampling rate is nothing but my Nyquist rate. So what is the condition for Nyquist rate? Fs should be exactly equal to 2Fm. So here the value of Fm or Fmax is taken as 4 kilohertz. So it is going to be 2 into Fm is nothing but 4 kilohertz. So what is the value of Fs? 4 into 2 will be 8. So the answer will be 8 kilo. The unit is samples per second. So the unit for sampling rate is 8 kilo or 8000 samples per second. This much number of samples are minimum required to avoid the aliasing problem. So that is what is understood from this problem. Now, so we have discussed the signals. Now we are going to go for transforms. So transforms. So if you take transforms, what do you mean by transform? Transform is nothing but changing something, yes or no? So I told that my signal can exist in both time domain as well as in frequency domain. So transform is nothing but converting a signal from either one domain to the another domain and vice versa. So that is why we call it as transform. So there are different types of transforms available based upon the nature of the signal. First one, for analog signals and for digital signals. So these are the two broad classifications of signals. So what are the various type of transforms that I am going to apply? For analog, so we have got first one, Fourier transform. Second, Laplace transform. Fourier transform. Laplace transform. Under digital, we have got DTFT, discrete time Fourier transform. That is nothing but discrete time Fourier transform, DTFT. Second, Z transform or Z transform. And third one is DFT, discrete Fourier transform. So these are the broad classifications of the transforms based upon the nature of the signal, whether it is analog or digital. So here, first I am going to see about, we will see in detail about only the analog transforms. That is about, briefly we will discuss about Fourier and we will deal exclusively in detail with Laplace alone. So Fourier and Laplace are going to work only on analog signals. So Fourier transform is nothing but it tries to convert my time domain signal into frequency. So both these transforms converts a time domain signal to a frequency domain signal. So it converts the signal from time domain to frequency domain. So they are closely related with each other. So if x of t is a time domain signal, if you take ft, that is Fourier transform on this time domain signal, it becomes capital X of j omega. So omega is the angular frequency. So this is the concept. So if you take Fourier transform on a time domain signal, its corresponding frequency domain component of frequency domain transform will be x of j omega. Now, similarly, if I take Laplace transform, it is also going to give a time domain signal. So x of t, if we take Laplace transform, it will get x of s in the frequency domain. So based on this, I can correlate a relationship between my Laplace and Fourier. So if we equate this, what will happen? S is equal to j omega. So the Laplace component s is related to the Fourier component by this relation s is equal to j omega. Now s can be further written as sigma plus j omega. So if s is equal to j omega, then naturally sigma should be equal to 0 for Fourier transform. Now, this is the relationship between Laplace and Fourier. Now, I have to discuss in detail about Laplace transform on analog signals. How Laplace transform can be applied and how it can be seen. Now, so we are going to discuss about Laplace or Laplacian or Laplace transform. LT. So Laplace transform has a particular definition. So Laplace transform is given by, or it states that if x of t is the input to a particular system, so this is my input to a particular system whose impulse response is given as h of t. So this is a system whose impulse response is given as h of t, and output will be what? Y of t is my output or the response of the system to x of t. So how does it relate these three things? So Laplace transform LT states that for a given system whose impulse response is h of t, its corresponding transfer function becomes, so if we take Laplace transform on h of t, it becomes h of s. H of t Laplace transform becomes h of s. Similarly, if we take x of t is the input, if you take Laplace transform, it becomes x of s, and the output y of t is nothing but the overall response of the system for the input x of t. So if you take Laplace transform, it becomes y of s. So Laplace transform gives a relationship between these three quantities, x of s, h of s, x of s and y of s. How does it relate? So it states that the overall transfer function for any system h of s is given by Laplace transform of the output, Laplace transform of the output divided by Laplace transform of the input under zero initial conditions. So zero initial, so the initial conditions must be considered as zero. So when I discussing about Laplace transform, one day asked where it's what are the possible applications for this. So mainly they are applying Laplace transform in control systems to analyze the response of the system. Analog control systems they are using this. So what will happen? X of s is the overall transfer function which is given. What is Laplace transform of the output here? It's given as y of s divided by x of s under initial conditions, to be 0. So this is the overall expression for the Laplace transform for a system, for analyzing a analog system. So h of s is equal to y of s divided by x of s under the condition, the initial conditions are being 0. Now we will analyze this with a particular problem. Kindly make a note of it. So this is make note of our problem. If the input response to a system, the input to a system, x of t is given as del of t. So x of t they are taking as del of t. Now they are given the differential equation so this is the differential equation they are given. They are given the differential equation. They are given the differential equation like this one. They are asking to find what is the transfer function by using this Laplace transform. They are asking to find the transfer function h of s. So how to calculate this? How to find this transfer function. Now we know that the expression for transfer function is given as Laplace transform of the output divided by Laplace transform of the input. So what will happen? X of s, if we take Laplace transform of del of t, is going to be 1. So if we take Laplace transform on this differential equation, what do you get? Considering this initial condition to be 0. So what do you get? So s square. So since it is second order derivative, x squared will come into y of t becomes y of s plus 5 into, since it is first order derivative, it will be replaced by s. So already I discussed about this the relationship between differential and integral on applying Laplace transform. Already you know. So this becomes y of s plus 2 is equal to 10 into, if we take x of t, so x of t is what? Laplace transform is del of t, so it's become 1. So 10 into 1 will be 1. So if we take the common, what will you get? S square plus 5s so this becomes s squared plus 5s plus 2 into y of s is equal to 10. So if you take cross multiply this, 10 into x of s. So what will be h of s now? So nothing but y of s divided by taking this x of s to the other side. So 10 divided by s square plus 5s plus 2. So this is the overall transfer function what you have achieved for the given input as well as the differential equation. So I hope that you had
two y of t.
Sorry. So it's become y of s. Okay. So I hope that you have a clear understanding of what is we had a enlightening session about what are the types of signals available and what are the drawbacks of each and every type of signal. So what do you mean by sampling theorem? So all these things also we have discussed about what are the various transforms available, and we have discussed the concept of Laplace transform with an example. So how to, where Laplace transform can be applied and how to find the transfer function. Thank you so much.